Dr. Jean Scholtz had a friend whose mother lived alone. In an effort to give her mother some companionship around the house, Dr. Scholtz's friend gave her mother a cat. She loved the cat. It was fluffy, it purred, it curled up in her lap.
She loves this cat. And she called her daughter one day and she was very upset.
This is Dr. Scholtz. The cat hadn't moved and it was clear something was wrong. The story has a happy ending, though.
And her daughter just went over and replaced the battery.
Robotic devices are increasingly finding a role alongside people, and the forms these robots are taking go beyond just a household pet. Some conditions are too dangerous or too mundane for people. In this episode, we look at humanoid robots and how they've stepped in to take some tasks off our hands. One, named Manny, spent a lot of the 80s being shot with a flamethrower. Another, R2, is currently doing chores in space. So here's an idea: humanoid robots. We look at how these robots have evolved, how some are even beginning to think like humans, and we return to Dr. Scholtz to find out how these advanced capabilities are changing the way we interact with technology. The world's first full-scale, fully functional humanoid robot was introduced in Japan in the early 70s by university researchers in Tokyo who called it Waybot. Waybot was truly groundbreaking, with a limb control system, a vision system, and a conversation system, allowing it to walk and communicate with a person in Japanese. But the humanoid robot race really picked up in the 80s. Waybot 2 debuted in 1984 as another first, the first musician humanoid robot. Here he is, getting introduced at a World Expo in Japan.
科学万博の見どころの一つとして人気を集めたのが様々なロボットです。こちらは
Waybot 2 could converse with a person, read a musical score, and play songs of average difficulty on an electronic organ. And in 1988, back in the United States, in Richland, Washington, a team at Battelle's Pacific Northwest Laboratories built a mannequin robot named, well, Manny. Manny was a full-scale anthropomorphic robot with 42 articulated joints and degrees of freedom. The lab was an R&D organization and was contracted to test protective clothing used in hazardous environments. You may have seen the early versions of these kinds of tests. Manny happened to get dressed up in a fire suit and then shot with a flamethrower. Dating back to the 50s, mannequins were even used in nuclear tests to help show the effects of nuclear weapons on humans. But there's a problem with these kinds of tests. The lifeless models, unsurprisingly, don't move like humans.
They're static mannequins, and they don't do a good job of really testing where these suits might fail.
This is Gordon Anderson, one of the original electrical engineers on the Manny development team. His responsibility was to oversee the significant amount of computers and electronics required to control all the different joints in the body.
So the idea is you dress the mannequin in protective clothing and put sensors on his body. That way you can then expose them to chemicals, expose them to fire, and find out where the suit has failure. And you can you can have the mannequin move in a lifelike way.
Coming out of Manny's back was a support arm that helped the robot simulate walking, bending, squatting, and crawling. Each of the roughly 40 articulated joints had a separate computer responsible for controlling the position. So these 40 computers then talked to an intermediate computer, a kind of traffic cop that then sent the information to an even higher level computer that initiated the lifelike actions of a firefighter.
For example, a firefighter may be crawling into a building, so he had to be able to simulate crawling kinds of motions, certainly walking kinds of motions. You may have to lift things up or raise things above your head. So we needed to go through all of those motions that a person would do and be able to use the limbs of the robot over the same kinds of range of motions that a person has, and that's where things become challenging from a mechanical engineering perspective, because your body's an amazing device in terms of all the joints and all the degrees of freedom and motions that you can go through. Now, we certainly can't do everything, every motion that a person can, but we with those roughly 40 joints, did a good job of simulating all the gross motions, turning the head and your neck motions and all those things we could exercise.
Manny had a flexible plastic skin and an artificial respiratory system. By injecting moist air at the nose and mouth, Manny could inhale and exhale. Manny could even sweat. Perspiration was simulated by using narrow tubes to inject water at places on the skin surface. Manny was lifelike.
Well, it gave you a huge respect for the human body, the range of motion, the complexity of the joints. This robot did not have fingers and toes and hands that were articulated, but just your hand has 27 bones and 39 muscles. It's just the complexity of the body is amazing. And then to design mechanical joints that would give the appropriate range of motion so we could do a good job of testing the clothing was a huge challenge. And then on top of that, the problem that we all learn how to do at a year or two of age of standing, balancing, and walking, that seems like such a monumental task from where we were when we developed this robot, because the electronics was larger in volume than the robot itself was.
During the 2 years of the development, Gordon said the biggest challenge was probably establishing reliable communication between all the computers that needed to send information back and forth.
Let's say, for example, we wanted the mannequin to walk. We would have to develop all of the angles of, all the motions for all the different limbs, and then write a scripting language that we could send to the mannequin's computers to tell it to operate that way in a coordinated way. So we had 40 computers, one on each joint, and they all had to operate in a synchronized way to control all of these joints.
Gordon and his team tried to simulate as many motions as a person would go through wearing protective clothing. So after 2 years of writing scripts to get Manny moving, the project was complete. Manny even had some game.
One day in the lab, we were just goofing around. We took a Nerf ball, and we had Manny hold the Nerf ball in his hand and drop it and kick it, and we kicked it into a trash can that was a few feet away. It took us a few tries to get it, but it was part of the fun of having everything working. We could do some stunts like that.
That said, Gordon's team didn't have the objective to make Manny balance or to put all kinds of electronics on him. That was a bridge too far at the time, he said. He's amazed, however, at the progress that's happened in the last 30 years or so. By today's standards, Gordon says Manny's actually pretty crude.
Our objective there, again, though, wasn't to try and make it walk. I mean, if they would have came to me in the 80s and said we had to make this thing walk, I would have said, yeah, good luck with that. But today, they're doing that.
One robot that has learned to walk is the Robonaut 2, or R2, a humanoid currently hanging around the International Space Station.
These legs aren't like our legs. They look really more like robotic manipulators. There's 7 joints in them. They have 2 knees, if you will, and it's pretty creepy to watch it climb around.
This is Dr. Julia Badger, one of the original developers and NASA's current project manager of the Robonaut 2, the first humanoid robot in space. Primarily made of aluminum and steel, the 330-pound robotic assistant is about 3 feet tall from waist to head. Although R2 doesn't have the moves yet to beat you one-on-one, the robot does share physical attributes with an NBA player and a certain Hollywood action star.
So it's about the size of a suited astronaut, or it's got the wingspan of Yao Ming and the bicep circumference of Arnold Schwarzenegger at his prime.
But R2's particularly innovative capability has always been easy to grasp.
When we built it 10 years ago, I would say that the hands and the dexterous hands were probably the biggest advancement in the state of the art. Since then, I think others have caught up to those hands, but the ability of our hands to be able to, flip tiny switches, unzip a zipper, and write, do a lot of things that are very, very dexterous. We've done surgical tasks with a Robonaut. We used a US ultrasound and those sorts of things. And the additional to be able to impart, we can hold a 20-pound weight with the hands at the same time. That was a huge advancement that is just now we're starting to see those types of abilities pop up in industry.
When Robonaut 2 launched to the space station aboard the Space Shuttle Discovery in 2011, its main job was to demonstrate to NASA engineers how well dexterous robots behave in space and microgravity environments. Not to put too much pressure on R2, but the hope is that someday, if all goes well, robots like the Robonaut will venture outside the station to help spacewalking astronauts as they make repairs. For now, R2 has been mastering more basic maintenance tasks, often with the help of a remote operator base on the ground.
We've been working on particularly logistics management types of tasks, like going and finding cargo transport bags, loosening them from their restraints and pulling them out of their stowage location, moving them to another stowage location.
Although R2 can understand some basic verbal commands and simple keywords, astronauts typically don't really work alongside the robot in the sense that you may be thinking.
We're not necessarily thinking that the Robonaut is sitting there waiting for the astronaut to give it a task or ahead and hand it a tool or those sorts of things in most circumstances, that it's more used as a tool to set up a workspace before the astronauts get there or to maintain a spacecraft while astronauts are not there, or do other things that are kind of that the astronauts aren't wanting to do, like clean. Every Saturday morning they have to clean the spacecraft, and so having a robot go around and clean instead of having the astronauts do it is kind of how we envision Robonaut being used.
Overall, there's a cost and complexity to creating human robots, says Dr. Badger, but there is a value in having a viable spacecraft that can be used and maintained even when humans are not on board.
Spacecraft now and of the future are going to be heavily mass constrained, mostly because the putting it into space on a rocket is probably one of the more expensive parts of the whole endeavor, and so it's important to be able to maintain that spacecraft when crew members are not around.
Ideas for the Robonaut can be applied on Earth, not just space. Here on Earth, work from the robot could support new ideas and tasks requiring a human-like presence in an environment too dangerous for humans, say a nuclear disaster site or an area with a bomb. Badger also imagines a softer kind of application, particularly as folks age and may require a kind of human or human-like interaction.
I think that having, if you can have a robot in the house with somebody, you can basically have that person in their house longer before they have to go into some sort of group or nursing home setting, because you could have the robot take on some of the household tasks. I think that's an excellent goal for humanoid robots in the future. We can see Robonaut being kind of a Rosie from the Jetsons.
Which brings us back to the cat. Many of today's robots are really impressive in their physical capabilities. Their strength, their speed, their ability to move. Boston Dynamics created a robot that can do backflips. The same company created a robot dog named Spot, which can run down a flight of stairs and even do the dishes. A recent DARPA competition showcased robots that could bust through doors and move across uneven landscapes. But now, instead of backflips and breaking and entering, today's robots are being asked to have a gentler touch, an ability to understand. Dr. Gene Scholtz, the computer scientist at Pacific Northwest National Laboratories, who began this episode, evaluates how humans interact with computers.
We're switching from people doing these automated tasks with robots or these physical tasks with robots to people now using automation for more mental effort. And that's going to be very different and very interesting, because these are, do you really feel comfortable letting a automated system make some of your decisions for you?
Well, do you? Do you have faith, for example, that autonomous vehicles will stop when you need them to, or that a robot won't hit you with a backflip while it works alongside you? To support new kinds of robotic assistance requires the processing of big data. In a method known as deep learning, machines are being trained to make decisions based on samples provided by scientists like Gene Scholtz. By learning through images, for example, a computer can learn to tell a dog from a wolf. Or an autonomous car can potentially use deep learning methods to spot a road sign or an obstacle.
This is a challenge nowadays, too, to make sure that we give them the right sets of data that they can take and process, and that they learn characteristics that are sufficient for making these decisions accurately. How many times does a system have to be wrong before I don't trust it anymore? And how long does it take me to build up trust in the system? And what kind of a task, what's the risk involved? If I'm using it to make a decision, and it's a very serious decision, somebody's going to go to jail if we make say that this is true. how does that influence how I trust the system?
But trust seems to already exist, at least in small degrees, enough to bring robotic pets to the living room. We're even beginning to trust how technology speaks to us. Take chatbots, artificial intelligence systems that interact with users via messaging, text, or speech. Chatbots are everywhere, from online customer service platforms to Alexa to Siri to Facebook Messenger, and it's a growing industry. In fact, the voice you've been listening to this whole time, me, Billy Hurley, I'm actually a chatbot. I'm just kidding, I'm not. Dr. Leslie Blaha is a mathematical psychologist and colleague of Dr. Scholtz. It's her job to leverage models of cognitive human behavior to add a more lifelike intelligence to robots, smartphones, and other form factors. Dr. Blaha has learned a lot about the machine intelligence supporting systems like chatbots, and what the chatbots say about human nature, specifically how willing we are to trust a Manny, an R2, or a talking bot.
You find some really fascinating things like very human behavior based avatars that are in essentially virtual therapists. There are patients who will open up and talk to these machines more than they will talk to other people because they don't think the machine is judging them the way other people do. And there's been chatbot research showing that teenage girls will chat to a chatbot for hours.
So, can we expect a Rosie from the Jetsons in our future, chatting it up and throwing out one-liners?
As far as somebody like Rosie from the Jetsons, I don't think we'll get quite that sassy. Humor is very hard to capture in a program. There have been some excellent strides in natural language processing and machine learning to help that, but still not quite to the level of natural human communication yet.
Punchlines aside, every day we're inching closer to robots that act more like humans. Leslie has faith in the robot's ability to provide a meaningful connection with people like the elderly, trauma patients, children with autism, and others who require human-to-human contact.
I am most excited about how the work in robotics and machine intelligence actually tells us more about human nature. The more we work with robots, the more we learn about people, which makes our robots better, but it also helps us make people and our environment work more effectively for each other.
The timeline of human-like robot development is a long one, and the skill sets have been diverse. One may play the organ, another may move supplies around the space station, another may crawl through fire. Although the capabilities vary, they can all tell us a little bit about ourselves. Humans learning humans from humanoids. This has been an episode of Here's an Idea. I'm Billy Hurley for Tech Briefs Media. For more news about innovative technologies, you can follow our stories every day at techbriefs.com. Here's an idea. Send us feedback to feedback@techbriefs.com and let us know what inventions you'd like to hear more about.